In this video, I'm going to give an introduction to pointers in C. So normally with these tutorial videos, I like to do live coding demonstrations, but pointers are tricky enough of a concept that it's going to benefit to do some visualizations, so I've made some of those as well. So first off, when it comes to pointers, if you're having trouble understanding these, don't worry. Pointers are one of the trickier things to understand in C programming, and honestly, they're really one of the trickier things you can understand in programming in general. They're just kind of hard to wrap our heads around. So what pointers are about is memory addresses. And normally our program and our data are stored in RAM. And we can think of our program instructions as being stored in a certain part in random access memory, the RAM you get on your computer. So when you get like a computer with 8 gigabytes of RAM or 16 gigabytes of RAM or whatever it is, that memory is RAM. And our program is stored in that RAM. And data that our program uses, like variables, will also be stored in that RAM. And all the memory addresses, they all have some number. So like house numbers, right? You have 15 Main Street, 25 Main Street, 100 Main Street. Same idea with memory addresses on a computer. They have some number that specifies like that slot of memory, that position in memory. And memory just stores data. Memory just stores zeros and ones essentially. And one of the things it stores is our program, but another thing it stores is our program's variables. So when our program creates variables, whatever they are, variable 1, variable 2, variable 3, when our program creates these variables, those variables are also stored in memory. The data associated with them is also stored in memory. And so here we've got like variable 1, variable 2, variable 3 that have positions in memory, addresses in memory, 2000, 2001, 2002. And our program uses those addresses. And really the variable is really kind of an identifier for that address. It's really a kind of like a name for that address really. So you call the variable X, but your program is really using memory address 2000 that the compiler has specified as being for variable X. Now with memory addresses, they're going to store some value. So, and it doesn't matter what really the value is. It could be part of a string. It could be an integer. It could be a double, but they're going to store some value. And we have some kind of unique positive integer for each memory address. So when you have some variable like my identifier, that is actually really a reference for some address in memory. And that's the position where the variable's data is stored. And it's going to be a number because like all things in computers are ultimately numbers like zeros and ones. That number could represent a character or something like that, but it's ultimately some number there. Now, when it comes to pointers, pointers are variables that store a memory address. So that's all a pointer is. A pointer is a variable that stores a memory address. Now, typically, pointers are going to hold the memory address of another variable, and we're going to say that the pointer points to that other variable. That's where the term pointer comes from. And pointers have a type, but the type is actually of the variable that the pointer is pointing to. So the type of the thing that the pointer is pointing to. So if you have something like int star a, what that's going to do is it's going to declare a pointer, but it's going to declare a pointer variable that points to an int type variable in particular. So a will store a memory address, and we expect it to store the memory address of an int variable. So we say that a pointer points to a variable when it stores its memory address. So if you have a variable x that stores the value 42, and p is a pointer and p points to x, then what p is going to store is the memory address of x. So it actually looks like this. So if you had, let's say, two variables, a and b, and they each have these memory addresses, like a has 0001 and b has 0006. If a stores as a value at that memory address 0006, we would say that a points to b because a is storing b's memory address. And so we would say a points to b. And that's what a pointer is. That's all really a pointer is that a pointer stores a memory address. And that's the biggest thing you got to remember when you're trying to understand how pointers work. So let's actually code up an example of this now. So let's zoom this back, and then we'll make some example pointers here. So let's make a variable b and set it equal to 42. Then let's make a pointer a. So I'm going to say int star a. So this is going to declare a variable a that is going to be a pointer. So the star means that make a pointer here. And the int means that a is going to point to int values. Now, what we'll do to have A point to B is we're going to use this operator AND, because to have A point to B, what we need to be able to do is have A store the memory address of B. That's what we want to do. Now, if we want to do that, if we want to have A store the memory address of B, we need some way of getting the memory address of B. And that's what this AND operator does. So AND and then some variable will give us the memory address of that variable. So I'm going to say int star A is equal to AND B. Now at this point, A is pointing to B. So what does that mean? Let's print out the actual memory addresses to see what this means. If we do a printf, and I say, let's do a printf of a couple things. We'll say, let's do a printf of B, just see what's inside B. B is going to be 42. We know that, but let's just print it out anyways. Then we'll do a printf of, we'll do AND B. And we'll do percent, I'm going to say %p here. %p is how you can print out a pointer value or a memory address. And I'm going to say AND B. Then I'm going to do printf, and I'm going to do printf of A, and I'm going to say %p/n, and I'm going to say A. And so we're going to print out the value of B, the memory address of B, and the value of A. And the value of A is going to be the memory address for B because that's what we set it to. So let's do a compilation here, and then we'll run it. And we get that B is 42, and B is this value. And you can see that A stores that value. They're the same. Now what this means is that we have this situation now where A is storing the memory address of B. Now, when we've got that, what that means is that we can actually use A to modify the value of B. So we can actually use the pointer to actually access the value contained in B. So to do that, what we're going to use is the star operator. So the star operator allows us to what's called dereference a pointer. When you dereference a pointer, you're accessing the value in the variable at the memory address stored in the pointer. You're accessing the data that is being pointed to. So we're going to say this. We're going to say here, star A is equal to, and I'm going to say here 50. Now let's print out these things again. Now let's print out B and these different values here again. So we'll print them out again here. And we'll do a clear, and I'm just going to run it again here now. And I get here, B is 42, and B is this, and A is that. But now I've changed B to 50. How did that happen? I never set B equal to 50, and yet now B is 50. And B is still the same before, and so is A, even though I said that A is equal to 50. So I didn't say A is equal to 50. I said star A is equal to 50. And star A basically says, go get what A is pointing to and use that. And we can use it in expressions, or we can use it in assignment statements like this, where I'm saying like, go get what A is pointing to and modify that. So it's kind of like if we had, on this, in this graph here, when I say star A, I'm saying don't modify A. I'm saying modify B, modify what A is pointing to. And that's what dereferencing a pointer does. Dereferencing a pointer goes and gets what the pointer is pointing to and works with that. And those are the two operators that really matter the most for pointers, is the AND operator and the star operator. And again, the AND operator gives you the memory address of a variable. The star operator is going to dereference a pointer and go get what a pointer is pointing to, and will let you work with that. So why do this though? Like, why have a variable that is a pointer to another variable? What's the purpose of this? So there's two big reasons why we use pointers in C. One is it allows us to do what's called pass by reference, or more accurately, pass by pointer. And that's when we use pointers to allow us to make a function that can actually modify multiple variables at once. And we actually have an example of this already if you think about how scanf works. And I'll show you an example of that. Now, another reason why we use it is what's called dynamic memory allocation. And that's where we can allocate space for things we want to use in C with a varying amount of space at runtime. In other words, we can decide how much space to allocate for something as our program is running. And I'm actually going to make tutorial videos for both of these concepts separately because they're both big enough of a concept that we should cover them separately. But I'm going to go over the ideas somewhat in this video as well, just that way you can see why we're going to actually use pointers. So I'm going to say here int a, b, c. And I'll say a is equal to b is equal to c is equal to 0, just to initialize all of them to 0. I'm not sure if you know you can do this or not in C, but if you set c equal to 0, the result of this is going to be 0. It's going to return 0 essentially, and then b is going to be set to 0, and then a is going to be set to 0. So this actually sets all of them to 0 just to initialize them. So let's do an example though. I'm going to say printf, and I'm going to say enter 3 numbers. And we're going to ask the user to enter 3 numbers. Then I'm going to use scanf here, and I'm going to say %d, %d, %d. And I'm going to say here and a, and b, and c. And then I'm going to say printf, and I'll say result, %d, and I'm going to add together a, b, and c, and print out that as a result. So what's going on here with scanf is that I'm giving it here and a, and b, and a, and c as arguments. Now, if you've never seen scanf before, what it allows us to do is receive input from the user. And amongst other things, it can also receive input from standard input, it's called. So it can actually do a little bit more than that. But what it's doing in this case here is it's going to accept 3 numbers from the user, 3 integers, and we're going to store them into A, B, and C. So how is this that the scanf is able to modify A, B, and C? How can it do that? And we'll give it a test here just to see that I'm not making this up here. But scanf is going to be able to modify all these variables here. And if oops, did I mess something up here? What did I do here? It says, oh, I forgot to say printf here. I just said print. I'm thinking of Python or something here. So, okay, we'll compile it again here. Enter 3 numbers. I'll say 5, 10, 2, and we get 17 as a result here. And what's going on here is scanf is modifying A, B, and C. The reason why it's able to do that is that we're not passing A, B, and C to scanf. When we pass arguments to a function, what the function gets is the value of that variable or that expression or whatever we've put as an argument. So if I were to say like a here, pass in a, what would be passed in is 0 because that's the value of a. If I say and a, what gets passed into scanf is the memory address of a. And scanf is able to use that memory address to modify a. And this is what's called pass by reference. Or if we really want to get technical, it's called pass by pointer in C because we're using pointers. Pass by reference is technically slightly different, but most people just call it pass by reference in C anyways. Let's make our own pass by reference function in C using pointers. So I'm going to make a function here called swap. I'm going to say void swap. I'm going to say int star A, int star B. So it's going to take in 2 values and we're going to swap these values. But what it's going to take in is actually memory addresses. So it's going to take in memory addresses that point to those values we want to swap. And so the value in this case is actually going to be a memory address similar to scanf. And we're going to use that pointer to actually swap the variables. So I'm going to say here int temp is equal to 0. I'm going to say temp is equal to star A. I'm going to say star A is equal to star B. Then I'm going to say star B is equal to temp. And we're going to use this function here to swap 2 variables using pointers. So let's actually make a little test of this now. I'm going to say here int AB, or maybe I'll make them different just that way it's clear. I'll say int xy. I'll say x is equal to 5, y is equal to 10. Then I'm going to say swap, and I'm going to give it and x and y. Now what's going on here is that we're not passing into swap the value of x and y. We're not passing in 5 and 10. We're passing in the memory address for x and the memory address for y. And swap is going to accept those, the memory address and the memory address. And A is going to be set to the memory address of x, B is going to be set to the memory address of y. Then when I say temp is equal to star A, what's going on here is we're dereferencing the pointer. And we're actually accessing, at that point, the variable x. Because we're dereferencing the pointer. We're going to be accessing the variable x in the main function. And we're going to be setting temp to that value there, to the value of that variable. Then when we say star A is equal to star B, we're saying go access what A is pointing to, set it equal to what B is pointing to. And we're accessing at that point the values contained inside X, Y, and we're setting them with the assignment here, and we're using them in the expression here. And then finally, when we say star B is equal to temp, that'll complete the swap of the two variables. This is a common algorithm for swapping two variables, to use a temporary variable like this to store one of the values while you overwrite it with the other. And we'll actually now just do a printf here, and we'll just see that the swap is occurring. So I'll say printf, I'll say x%d, y%d /n. We'll print out x and y, and then I'll do a printout of x and y afterwards. And we'll just print this out, and we'll just run this code here after we compile it. And we get that x is 5 and y is 10 before, and then after x is 10 and y is 5. And again, what's going on here that's key to understand is that we're passing in the memory address, and that's what allows swap to access both of these variables here in the calling environment main. So let's just do a printf actually of and x and y. Let's do a printf of those values too. I'm going to print f and x and y, the memory address of each. So I'll say %p, and we'll print out and x and y. And what we're going to find, and I might actually put a new line between these as well. Put a new line there too instead. What we're going to find is that they're going to be equal to a certain memory address that looks like the memory address that we had before for A and B. But what I'm also going to do is inside this function here, I'm going to print f the memory address of A and B. Just that way it's clear what's being given to this function here. So I'm going to print out A and B because A and B are pointers that store a memory address. So I'll print out A and I'll print out B. And we're going to find that when we do this, that A is set to the value of the memory address of X and B is set to the value of the memory address of Y. So we'll say gcc-out demo.c, run this here, and we get that and X is this, and A is this, and they're the same. And Y is this, and B is this, and they're the same, right? So what we did was we gave it the memory address of those two variables there. And then what's happening in this swap is when we say star A and star B, we're getting at the values that are pointed to by the memory address contained in A and B. We're accessing those values. So if I were to do a printf here, let's do a printf here of star A and star B. We'll say here star A %d, and we'll say star B, and we'll say %d, and we'll output the value we get when we dereference the pointer A and dereference the pointer B. And we're going to get what A and B are pointing to at that point. So I'll run this again. And we get that A is 5 and B is 10. And it's not A, I should say. I guess I should say that we dereference A and we get 5. We dereference B and we get 10, right? And that's because when we dereference it, we go get what is at this memory address, and X is at that memory address. And that's when we actually access the X value. We can access the Y value similarly when we dereference B. And so that's what's going on there. And that's one of the things that a pointer allows us to do, is to do this sort of pass by reference technique where we can have a function that is able to access and modify multiple variables in our calling environment for that function and alter them as it pleases. And that's, again, pass by reference, or more technically called pass by pointer. Now, the other thing that pointers allow us to do is what's called dynamic memory allocation. And dynamic memory allocation is where we want to have some chunk of memory that's allocated at runtime. So as our program is running, we decide to allocate a certain amount of space at runtime. So if I normally declare an array, say in C, I could say like int A is 10, and at compile time here, what's happening is I'm deciding to have an array that is going to be of length 10. But what if I don't know at compile time, when we compile our program, how large of an array I need? What if I ask the user, like, hey, how many employee salaries do you want to enter? Or, how much of this kind of data do you need to record? At that point, I might need to allocate space dynamically at runtime as my program is running. And that's where dynamic memory allocation comes in. And again, I'm going to make another tutorial video on this because it's a big enough subject, but I wanted to put in this pointer video too, just to give you another example as to why pointers are useful. So what I can do is this. I can say here int star A, And this is going to be a pointer to what we're going to call a dynamically allocated array. And what I'll do is I'll have a size of that array. So I'll say like int size, maybe I'll call it length. I'll say int length. I can initialize it to 0. And I'm going to ask the user to enter a length. So I'll say like printf, I'll say enter a length. And then we'll do scanf, and we're going to store the length. We'll say %d, and we're going to store the length that they enter into length. What I'm going to do is I'm now going to allocate space dynamically for an array of this length. So what I'm going to do is I'm going to say a is equal to, I'm going to say malloc, and I'm going to say length times size of int. Now what's going on here is malloc is a function that actually allocates space on what's called the heap. The heap is the area of memory that's for dynamically allocated things. And it's actually, if we think of our visualization here, it's actually kind of located at the bottom here. This here is what's called the stack, and it goes downwards. The heap is actually kind of at the bottom here, and it grows upwards. We can think of it like that anyways. And what we're going to do here is we're going to actually have A be a pointer to that newly allocated space that's been set aside for us. And what malloc takes in as an argument is how much space do you need in bytes? How many bytes do you need? And we're saying we need the length, so we need this amount of space, times the size that it takes to store an integer. And malloc is then going to give us that memory that we can then work with to do things like store data inside of it. So I could say at that point, like, okay, let's store in A, we'll say AI is equal to I. And we're going to store in A at position I, the value I. So we're going to store from like 0 up until the length that we've decided here. And I could print it out too. So I could like store some values in there, and I could print out things as well. So I'll say store some values, and I'll do some printing here too. So I'll say printf, and I'll say a%d is equal to %d. And I'm going to output the values that I just stored. So this will store some data for us in that newly allocated space. This will print out the values in that newly allocated space. And when you're done working with data that's been dynamically allocated, you have to free the space that you allocated. So I'm going to say free A. And what this does is it makes that dynamically allocated space available again. If it were to be, if it needs to be allocated again, say, it's now free to be allocated again. If I don't free it, I have what's called a memory leak, where I've got some memory that, can't really be used at that point. And so we have to free the space after you've allocated it. But in this case, A is again going to be a pointer. So if I were to do a printf here, and I would say like printf, and let's print out and A. I'll say, or actually I'm just going to say print out A. I don't need to print out and A because A is a pointer. I'll say print out A %p, and we'll print out A there. Okay. So, and the other thing I have to do is, because I'm using malloc, I have to include one more library. I have to include stdlib.h. So number include stdlib.h because I'm using malloc to allocate memory dynamically. So there's quite a bit going on here. And like I said, I'm going to make another tutorial video just on this, but I wanted to show you another example as to why pointers are important. So we run this here. It says enter length. I'll say 4. So I put in 4, and you can see that A is just some memory address. And what's happened though is that malloc has said, okay, return a memory address where basically space to store 4 integers has been set aside. And then A is then a pointer to that space. And it turns out we can actually use this array notation here to access the values that are stored starting at this position in memory. And that's another thing we would use pointers for, is this dynamic memory allocation, where now I can then say like, let's run my program again, and I'll say enter length, and I'll say like, 10, and I now have space for 10 ints in this dynamically allocated array set aside in memory, and you can see the 10 values there. And I can just dynamically allocate different spaces at runtime now, which is going to be important for all kinds of programs. So pass by reference and dynamic memory allocation are 2 important things that pointers are used for. And hopefully this video has helped you to wrap your head around pointers. But if you don't get them, don't worry. It's a tricky concept. It takes time, and just do a lot of experimentation, try out a lot of stuff, and eventually it will click. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.